And we're live in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we're live. Hello world, it's Siraj, and welcome to this live stream. In this live stream, we are going to build a new PC, my new PC with an Nvidia RTX 3080 GPU. And what you're seeing here is a demo of reinforcement learning using this library called miniworld. And I built this simple algorithm to train an AI. It's a pedestrian AI to avoid the roads. Normally you would, I guess, make a self-driving car AI that avoids the sidewalks and just stays in the lane. But in this case, I made a pedestrian AI that stays on the sidewalk. So it tries to walk from one end of the sidewalk to the other end of the sidewalk without touching the road at all. And that red box you're seeing is the reward that it's trying to receive. And you can see that this is on the new PC that I built, the RTX 3080, which I'm so excited about. I can't wait to share it with you. And that's going to be the video. That's going to be the topic for today, the RTX 3080. This is sold out everywhere online. And last week I lagged out of the stream. And so I just immediately found one because I was so motivated and dedicated to making these streams amazing for us all. So that's what we're going to do today. We're going to build this PC first, or at least look at all of the components. And I'm going to ask you questions like always about those components to make sure that you're listening. And at the very end, 3 people are going to win. This time it's $50 worth of Bitcoin each. And if you don't know, Bitcoin just went through the moon. So all of you who have been winning, if you've been holding onto your Bitcoin, you are now very, very happy. So I'm very glad to see that Bitcoin's price just keeps skyrocketing nonstop, as it should, and you know, we all hope it does. So the first thing we're going to do is I'm going to show you all of these parts of the PC. We're going to look at the internals. This is a 1080 Ti, an RTX 1080 Ti. This is the GPU I've been using for 2 years. You know, I got it in 2018. But it's time to upgrade. So let's get to the upgrade part, all right? So let's get right to the upgrade part in 3, 2, 1. Well. It looks like Bitmas is here early this year. This is the PC that I just built. It's an RTX 3080 GPU. That's really the core component of this PC that I want to stress to you that I care about the most. But let's take a look at all of the different components of my new PC, and then we're going to look at the code and go through the questions and the other parts of this stream, all right? So this is my new PC. It's got that RTX 3080 GPU. This RTX 3080 is really hard to find. In fact, let me just show you each of these components one by one, all right? So the first component is this RTX 3080 GPU. And this is sold out everywhere online. It's very hard to find this GPU, but it is part of NVIDIA's 3 series, which if you look at all of the benchmarks, at all of the performance tests, these 3 series GPUs just blow everything else out of the water. Now, the first GPU that I had was this 1080 Ti. Now, this has served me pretty well for 2 years, this 1080 Ti, but it's time to upgrade after 2 years, I would say. And so yeah, that's the 1080 Ti, and instead I've got the RTX 3080. But what else have I got? What else is a part of this? Well, there's this lighting system by Rosewell. So it's a Rosewell lighting system, pretty standard stuff, under $100. But then you have this little remote that lets you change the colors of your computer. So it's red, and now I can make it off, on, off, on, a different color, yellow, blue, and then how about rainbow? Okay, great. And that, doing a bunch of things. You know the deal. Yeah, so colors. Now, besides colors, what else we got? Of course, we've got to have the power supply, right? What is a computer without energy? Energy drives everything. It drives us. The sunlight, it gives plants energy, and then we eat those plants, and then we get that energy, and then we die, and it's just energy powers these computing devices. It's such an important component of computers. And I say that because certain GPUs won't work with certain power supplies. Like this RTX 3080 it's going to need at least a 750 watt power supply. This is a Corsair, you know, you'll find Corsair is pretty standard for power supplies. What else? And then we've got the motherboard. This motherboard is an X570 Aorus Elite. It's a gaming motherboard. And the reason that I like this motherboard is because it has so many PCIe ports for it. It's got 4.0, and it is an X64 compatible motherboard, which is perfect for the CPU that I bought, that I cannot wait to show you. Let me show you the CPU. So the CPU is a Ryzen 5000 series processor 7. And this is one of the fastest CPUs on the market right now. And I really wanted this CPU, especially for streaming quality, because streaming depends on bandwidth and on CPU, not necessarily GPU, surprisingly. But so that's the Ryzen CPU. It's compatible with the motherboard. The power supply is enough for the GPU. And then, of course, we've got these 2 sticks of 16 gigs of RAM. So I've got 32 gigs of RAM in this thing. Just an incredible amount of memory. That's going to be so necessary. And then secure storage, right? We've got 512 gigabytes of storage space in this thing. And then this is nothing. And yeah. And then the case is a it's a master cooler master case. It's a Cooler Master H500P. Anyway, let's take a look deeper at this PC, shall we? So let's open this up. You know what I need is I need one of those cameras that lets you put it on your head like a GoPro. But anyway, so we've got this, and we're gonna open this PC. Here we go. We're gonna open this PC. All right, there we go. That's how you open it. All right, let's take this baby out. Let's take a look in there, shall we? All right. So we've got the RTX right there. This is the 3080 GPU. It's got its own slot right here. In fact, it takes up 2 different slots. It's got 3 different ports for HDMI. Well, it's got 1 HDMI port, and then these are, I think, what are those called? DVI ports. But so here's the motherboard back here. We've got the 2 sticks, 2 16 gigabyte sticks of RAM, so 32 gigs total. The power supply is underneath here. I screwed it in, so it's, you know, it's not, we can't just take it out like that, but the power supply, that Corsair power supply, is right behind this. The cooling system is right here, and then that's what's powering this whole fan system. There's a liquid cooling system underneath here, but it's really tucked away and hidden. But really the brain of the computer is right here. You know, you've got the CPU, we've got the RAM, the short-term memory, we've got the long-term memory in terms of the secure storage device. We've got the 2 capture cards for streaming right there, and then we've got this liquid cooling system that goes up, this fan cooling system actually. But it all looks really nice, and you know, instead of having this 1080 Ti in there, we're going to use this 3080. And actually, we can go a little deeper in here and see, like, what do we want to do? Do we want to take this out? Look at how many pins this requires. This thing is a power beast. Like, you cannot just put like 3 pins in here. It takes 12 pins. And I had a problem with this, you know, installing this one at first because I didn't have enough pins, and I had to go back and add more pins to really power this baby. But yeah, you definitely need a 750 watt power supply for this thing. It requires a lot of energy, and so yeah, that's the computer. It's got so many ports back here. It's got like 6 USB ports. Actually, wow, it's got like 10 USB ports. It's got a lot of stuff. All right, so that's the computer. Let's now get back and start coding. All right, so that's the computer. All right, those are the parts. And now what I'm going to do is I'm going to ask you the first question of this live stream. And the first question is, how much does this PC cost? Like, It's kind of like The Price is Right. I don't know if you guys have ever played that game show, The Price is Right, but or have heard of that. But basically, you try to estimate the price of some product, and that's essentially how the show works. So, given all of those things that I just talked about, how much do you think that my new PC is going to cost? You know, we've got that RTX 3080. We've got that newer Ryzen CPU, one of the fastest CPUs on the market. And the motherboard is definitely not cheap. But that's a question for you guys. And while you answer those questions, I'm going to answer some of your questions. I'm going to answer 3 questions, and then we're going to keep going. We're going to start coding, all right? There's so much I want to show you about this GPU, all the capabilities. We might even be able to stream Cyberpunk 2077. It looks like there's quite a distributed, the answers are very distributed across all 4 choices, which means this wasn't a super, super easy question, which is good for me and you. The first question is from Cloudcast's Alan Smith. He asks, do you know what the status is for running Keras with Windows on the RTX 3000 series? It's going to work beautifully. Like, I haven't set up Keras specifically, but I've already seen like code snippets of Keras, and I'm super excited to do deep learning. Weirdly enough, I set up my computer for gaming even before deep learning because it's just easier. You just download a game and then install your CUDA drivers. Whereas for deep learning, you need TensorFlow, you need Docker, you need Python, the right version, and then you need CUDA and Jupyter Notebook ideally. 2 more questions. Tiago Rajan asks, can you talk about Bitcoin mining? Short, simple, and as elegant. Tiago Rajan, you know exactly what's been on my mind. I want to use this thing for some crypto mining, and I will. And I think that we all should be mining crypto because, you know, crypto is the future. You know, I've known that for a while now, and it's happening. And Bitcoin's going crazy right now, and it's just a great time to be in crypto. In terms of mining, I'll absolutely, yeah, let's do a video on mining. I'll get you guys all set up with your own miners, and you know, I'll set one up for myself, and then I'll show you guys how to do it. How does that sound? Right? We'll all have our miners running in the background, just mining like 12, 20 different new cryptocurrencies, and who knows, maybe one of them will like just skyrocket, and you'll get rich. So, yeah, let's do that. I think that sounds fun. One more question before we keep going. Related Title asks, what's the cheapest CUDA GPU you recommend? So at this point in 2020, like I realized that, you know, whatever cost this PC is, it's not affordable for everybody. In terms of the cheapest CUDA GPU, I would go for, it's really hard to go under the 1080 Ti. Like I've been spoiled with the 1080 Ti, and I just could not handle anything less than that. And that's what I would suggest, because at this point, it can't be that expensive. It's been 2 years. So let's see what the answer is, and then we're going to keep going with the code and then test out all of this GPU functionality. Let's see what the answer was. All right. The answer in 5, 4, 3, 2, 1. The answer was 5,000. Congratulations, whoever got that correct. I really, really admire that. Congratulations. All right. So now that we did that part, we are going to code. So who's ready to code on this thing? Let's bring up the coding window, and then we're going to get started with this. So many things to do. Where do we begin? I want to start at github.com, my favorite website. So let me pull up GitHub for you, and then we'll keep going. So github.com, I want to show you everything that we can do with wonderful GitHub, and we're going to look at some code. We're going to look at some reinforcement learning code. It's going to be a lot of goodies. All right, 3, 2, 1, GitHub. So on GitHub, let me make myself just a little bit. Okay. On GitHub, what do we want to do? On GitHub, let's search for something to test out this GPU, shall we? So I'll search for reinforcement learning. All right, reinforcement learning. And there's a million things for reinforcement learning. So let's pick this one. Oh, look at this assistive gym. I really wanted to try this. check this out. So this is basically this 3D environment for using robotics for older people, like people who don't have full control over their bodies, full range of motion, full muscular control. You know, how can we use robots to improve their qualities of life? And I think that that's a really cool use case for robotics, is like helping older people. In fact, that was my first startup, Lucid Robotics. It didn't work out because we were too early, but it's still a really cool idea. But anyway, I couldn't get this one working, so we'll have to skip that. But definitely take a look at that repository. So this is the one that I really like, Gym Miniworld. So if you don't know, now you know that Gym is a library by OpenAI that allows people to train algorithms in these nice little 2D and sometimes 3D, in our case 3D, environments. And the goal is to get these AIs to complete the objective, whatever the objective is. You know, find the reward, find the green dot, find the red dot, complete the maze, you know, whatever that objective is. And so let's just try this out. It seems pretty simple enough. It says that there are only 5 dependencies: Python 3.5, OpenAI Gym, NumPy, Pyglit for the 3D graphics part, and then a GPU, which is what we have, which is not really optional. We're going to need all of that GPU power. So let's clone this. So I'm gonna take this and clone it. So take that and clone it. We're gonna open up command prompt, and we're gonna do this right from Windows, just to show you how we're going to use this code right from Windows. So we'll open up command prompt, and we'll get right to Windows in 3, 2, 1. All right, so I want to make this bigger. All right, so what does it say we have to do? It says we have to make a new demo test, and then we'll go into demo test. We're in demo test. We'll initialize it as an empty Git repository. Git is not recognized, seriously? Oh, I didn't install Git on this new computer yet. That's fine. Is it really not installed? Should I just install Git for us? Install Git, Windows, just real quick so you can see how fast I'll install things. Let me also open up window capture. Yep. Downloads for Windows. 64 Git, 64-bit. It's downloading. Lag. Okay. Downloaded exe. And 3, 2, 1. Next. And it's just installing Git right now, but we'll have Git done in like maybe 5 seconds. 5, 4, 3, 2, 1. Installing. And then we can use Git to install this finish. Okay, so let's see if Git works now. Let's open up Git and see if it works. Okay. Git. Okay, fine. Open up a new one. How about now? Git? Okay, now it works. Okay, so what I had to do was say ls or dir for Windows, cd into the desktop, and then cd into demo test, and then git init, git clone. Miniworld is downloading, and once it's downloaded, we will install those dependencies one by one. Really want to do this. Okay, so we got it all. Install those dependencies. Cannot be found? What do you mean? Oh, we have to go inside. No. No. Yeah. Now we'll do the dependency install. There it goes. All those dependencies. Ooh, okay, totally installed. All right, we're good. Now let's open this thing up. So in Sublime Text, I will open up a text editor, and I'll open folder, and I'll open up demo test Miniworld. Now I'm going to show you my text editor so that Sublime So this is my text editor, Sublime, and we're just going to look inside this repository and see what's going on here. We have manual control.py. So this is the main class file that they said that we need to use, manual control.py. Okay, it doesn't seem that hard. It's just a basic bunch of command line arguments, import your dependencies, start the environment, and then perform a step. And a step is going to be whatever that environment is. Maybe it's one step forward, maybe it's pick up an object, but you can see all the potential actions that an AI can take in this grid world. It can move forward, it can turn left, it can go up, it can go down, it can even pick something up. There's a pickup button somewhere here. Yeah, right here, action pickup. So I can pick something up, and what these are just event listeners by Pyglet. So Pyglet is like a 3D framework for Python for running physics simulations, and it's in 3D. And there's an event listener that is just automatically called whenever an environment is initialized, and then we can add whatever code we want inside of this event listener. That's just luckily handily called for us, which is the case in iOS and mobile apps and some web apps as well. Event listeners are very useful tools for firing certain code in certain event. They're just listening for certain events. So that's what we have here. We kind of want to test this out though, right? We don't just want to just have that code. So let's run the code first before we do anything. So they say that in order to run the sample, we just type that in, manual control. So we'll do that, manual control.py. Let's go. And what you'll see is the result. And the result is this window right here. And in this window, we can move forward, we can move to the left. And so I'm pushing the arrow key. So left, right, left, right, forward. You see what I'm doing? I am moving this around in this 3D environment. So it's giving us the position, it's giving us the angle, it's giving us the number of steps. And we are doing this manually. So it's us in control. And I just got that reward. And so it's going to say reward equals 0.92, done. So that time step is done. Is it recording anything? Not really. It's just printing things out. This is just pretty printing for us. And so we're moving around this environment manually, looking for the reward. And once we find the reward, it resets, right? So what we want to do is we want to create an AI that autonomously gets that reward. So we'll X out of that, and we want to get an AI that's going to autonomously collect that reward. How would we possibly do that? So let's build that, shall we? We're going to build that AI with this new GPU. We're going to test it out, see how it works. So, and then we'll have a robot dance party right after we code this for I'd say 7 minutes. What do you think? Robot dance party? Sounds fun, right? So 7 minutes of coding, and then we're get to our robot dance party. So let's go up. So we're going to create our own little function here because we like doing things ourselves. We're going to call this, let me make this bigger. So we're going to call this function, what do we want to call this function? We're going to call it learning agent because we're going to learn some things. Learning agent, okay? So find this repository if you haven't, download it and do this with me. It'll be fun. Let's do this together. If you don't want to, that's fine. You can just watch. But so this is our learning agent function. It seems kind of cool, but we're going to work on it, make it better. We want to make a really smart agent that is going to autonomously complete the objective. Whatever that objective is, it's going to complete that objective. So, if we have this function learning agent, let's just say that to start, it's just going to print out hello world. That's it. And so that's just kind of to test that this is all working. And where do we want to call learning agent? That's the other question. Like right now, it's just got manual control. But let's say we want to make this autonomous. Where would we add this? Well, that's the great thing about event listeners. So notice this on draw function. This is called right when the game is, or the environment is initialized. So after Pyglet renders, let's say that, or rather, after, we'll then initialize learning agent. And, we could probably name this, we'll call it in the same format with the underscore and no uppercase. It's always different for different programming languages, like what that syntax should look like. But So that's our learning agent. That's where we're going to call it. And this is where we're going to define it right here, learning agent. So what is our learning agent going to do? Well, that is a good question. Should we do like the most advanced deep learning on the planet, deep reinforcement learning, X3, actor critic, throw some genetic algorithms in there, just mesh everything together? No, we're going to start with something really, really simple. And that is called a Monte Carlo prediction. So Monte Carlo prediction is one of the most simple reinforcement learning techniques. And the idea is that we let the agent try out a bunch of different things, and we're recording all of the states from all of those different time steps. And the states in this case are going to be a triplet of values. They're going to be what the agent observes. So that's the image frames, the pixel values of the image frames, the movement that the agent does. So it'll be some random movement, whether it's forward, backward, left, or right. And then the reward, whether there is a reward for that action or there is not a reward. Those three values we're going to concatenate into a single vector. We're going to feed that vector to this agent, and the agent is going to, in terms of Monte Carlo prediction, it's going to find whenever a reward is actually received. So it's waiting for that reward. Whenever a reward is actually received, it's going to compute it's going to store the steps that it took to get to that reward, and it's going to compute a value for all of those steps leading up to the reward. And so what it's essentially doing is it's storing in its memory the steps most likely to get to the reward. There's no neural learning happening here in terms of a set of weight matrices that are being updated like ones and zeros with backpropagation. So in this first version, there is no backpropagation. It's just using a single static memory data store to store certain states that are more likely to get the agent to the reward. And that's pretty simple, actually. And you'll find that out exactly right here. So where do we begin? So we start out with hello world, and then we're going to add in the not even a training loop, just a simple action. So we'll say action. This agent, when the game starts, it's just going to take a random action from the given possible list of actions. So this alone will create a random action. So all it does is it performs random action. So let's try that out. Let's run that, and we'll see if that actually it's only going to do one random action. We want to have multiple. So we'll say for t in range 1,000. So I'll do this 1,000 times. For t in range 1,000, render the environment. So we have to render every frame, and then we do that action space .sample. Yeah, something like that. And this goes away. Yep. So let's just try that out and see if that does anything. Console is not defined. Oh, it said console is not defined because it's got to be uppercase, I think. Oh no, it's print. What am I doing? Console.log? This is Python. Oh my God, I get my languages messed up sometimes. It's all good. Where are we at? No, it's print. Console.log. You guys are probably laughing. Ha. All right, let's see this. Manual control. Hallway object has no attribute action space. Okay, how about now? Good. So now what's it doing? Now what it's doing is it's just standing there. It's not really doing anything. And now I'm manually moving it. So what happens was it just took one random action, or no, it took a lot, but then it didn't like do anything with it. So now I'm moving it. Okay, so we've got to add more logic here. So clearly, at least it compiled and worked. So we know that we're writing something in here that's not like totally wrong. What is the next step for us to do? We've got to add some logic in here. But before we add some logic in here, we need to take a 1-minute robot dance party break because it's the 30-minute mark. Like I said, we are going to upgrade this code. I'm going to ask you the first question, actually. I mean, the second question. So I have question 2 coming up. But before we get to question 2, we have to have a robot dance party. What that means is while my Tesla is on autopilot, we will be dancing. So wherever you are, whether you're sitting or standing, get up, stretch a little bit, and it's time for a robot dance party in 3, 2, 1. Yeah. All right. That's the robot dance party. I hope you guys like that. All right. Let's get to question 2. And then we're going to keep coding. So question 2, let's pull up question 2. Question 2 is, which of these software tools is considered a virtual machine? Now, remember, those of you who actually read the video description links that I posted before this, as I always do, you'll be well prepared to answer this question because there was one particular learning resource that mentioned all of these. And it was I'll just give you a hint. It was that LLVM link by Chris Latner, the guy who made LLVM, Max Big Compiler. But so yeah, I hope you looked at that. Those who did look know the right answer to that. And it looks like there's quite a distributed set of answers here. So it's a good level of difficulty, I think. But which of these software tools is considered a virtual machine? Is it .NET? Is it LLVM? Is it GCC? Or is it the Rust compiler? And so that is going to be, it looks like people are really switching their answers. They weren't sure, but it almost seems like everybody is centralizing on one answer. Let me answer 3 questions and then we'll keep going with this stream, all right? Question 1. Arnav Jeswal asks, anyone know how to utilize GPU for deep learning using TensorFlow and Keras on Mac Pro 16 using AMD GPU? I need just like a deep learning tutorial video for every platform, don't I? With like a 10-minute video, 3 minutes Mac, 3 minutes Windows, 3 minutes Linux. But it's got to be the easiest platform. Windows, I think, is the easiest platform to install the deep learning tools on, weirdly, just because of the CUDA integration. But you start with CUDA, and then you go for TensorFlow, and then try out Jupyter Notebook and just like print out, import TensorFlow, compile it, see if that works. That's really the MVP. Second question. Can you please recommend a good course on machine learning for beginners after he has attended Andrew Ng's course, asked by Ahmed Siddiqui. So how many machine learning courses have I made on this YouTube channel? Let's go through my playlists. If you want to see some masterpieces of machine learning, go watch my Math of Intelligence playlist that I made in Amsterdam when I was just so in the zone in terms of combining art and music and machine learning and dance, and just, that was a masterpiece. That was like my beautiful, dark, twisted fantasy of machine learning. So the Math of Intelligence is a free one. Move 37. If you search Move 37, that's a free reinforcement learning one. I have a playlist called Learn Machine Learning in 3 months. If you search that, that's going to be super useful. And what else? I mean, Fast.ai. Fast.ai is a great beginner's deep learning course that's free as well. So I got to give a shout out to Fast.ai. And yeah, you got to learn by doing. I think, universities and the education system has convinced many, many people that the only way to learn something is to, pay Berkeley or to go use this brand name university or use this or that, or they're all wrong. And they'll never changed my mind, and I'm a constant learner. I love learning so much, but I hate school. I hate university. I hate classes. I hate tests and professors because I think all of that is not how learning should be done. You are witnessing the future of education right now. This is the future of education. So thank you for being a part of it. I'm so honored to have everybody here. One more question by Mosena Khalil asks, which processor is better, AMD or Intel? I'm going to have to go with Intel x86 processors. They're more powerful. They're not more power efficient, but they're more powerful in terms of the processing ability. Fewer steps, more efficient. And just I like Intel. And Intel's been around and they haven't like done anything weird or so. All right, let's see what the answer was before we keep coding. 3, 2, 1. Ba-ba-bum. The answer was .NET. Wow, most people did not get that. Most people thought it was LLVM, which makes sense because that was the topic of that learning resource that I mentioned. But that's not a virtual machine. If you actually read it, then you know it's not a virtual machine. So congratulations to the 9 people who got that one correctly. Very, very cool stuff. I love that. All right. So now we're going to keep coding before we get to the last question, and then we're going to announce our winners, and I'm going to do that freestyle for us. All right. So let's open up that window again. I think it was Sublime, right? It was Sublime. Yeah, it was Sublime. Gym Mini World. Wow, where did I put that Sublime? Oh, there it is. Okay. So, another thing I wanted to mention, guys, is that reinforcement learning is my favorite type of machine learning. It's also like the least, I guess, useful for production applications. You almost never see anybody using reinforcement learning for real world scenarios other than energy optimization or what else even, like self-driving cars. I guess that's a huge one, but very, very limited potential for applications. I think climate controlled technology, much like the Nest thermostat, probably uses reinforcement learning. At least I hope that it does because it's amazing. But anyway, why is it important if it's not used so much? Because it's the hardest of the machine learning subfields. It's way harder than supervised or unsupervised learning or clustering or regression or classification. It's just like a different 3D simulation, time-dependent paradigm for learning. And that's how we're learning, and that's how we need to think about computers learning. And as GPUs in general get easier to access and more people have access to computing power, I believe we're all going to be using these 3D environments to train our algorithms, not 2D. And it's all going to become more and more relevant to everyday applications. But it totally depends on computers becoming better and better over time so that we can all just party and have fun and love each other and discover things and create things while the robots do all the work. Doesn't that sound great? It sounds great to me. So where were we? We were building this learning agent. And right now it's just for 1,000 time steps. It's just going to perform 1,000 random actions. So we want to do something a little smarter than 1,000 random actions. So what we're going to do is we're going to say that we're going to create this static list. So it's just well, not static. It's going to be dynamic because we're going to continually append things to this list. But we're going to call this list episodes. And what we'll do is we'll say that when we have this action, we're going to perform that action using the step function. So now the step function is going to actually implement the action. So all we did was we initialized the action. The step function is what actually initializes it. And once we have the step function, then we can add in what the return values are going to be. The return values are going to be observation, reward, and done, and info. So basically these 4 values are going to return whenever our agent takes a step. It's going to be the observation, which is the state of the game. So that's just a 3x3 matrix of pixel values. So, an image is a matrix of pixel values 0 through 255, and that's what's going to be the observation for a time step. Reward, we can think of as 0 or 1 if we retrieve that red box in that time step. Done is just a Boolean, true, false, whether or not we receive the reward or not. If it's true, it automatically restarts the game. And then info, that's just logging functionality. That's, wherever, everywhere. But once we have this, observation, we want to do something with that observation. So we'll append our episodes list. Episodes episodes.append, and we'll create a triplet of values, a vector triplet. So reward, we don't need the info, so we'll just go for observation, action, and reward. What say you? All right, so we have that. And once we have that, the episodes as that, we're collecting all those episodes, and then we want to do something with those episodes. We don't just want to have them, we want to do something with them. And so for that, we're going to need to define a policy. So, I think that people often get really confused with the word policy and value, because these two words are often used very interchangeably in reinforcement learning. But let me just briefly do a little monologue on reinforcement learning policy and value functions. So the policy is such a meta concept that I think is so cool and so valuable for us to think about. Like, I think this is valuable because I think about this in real life. Like, what's your policy for life in your own? So your policy decides what the best set of actions that you should take should be to achieve your reward, whatever your objective is, right? And the policy uses the reward as a signal to update itself over time. But so, a very simple policy could be like, if the reward is red, then return 1. If the reward is green, return 2, or something like that. That's a simple one-line policy. But for more advanced agents, the policy is going to involve a neural network or some kind of weight matrix that's learned over time through calculus or some other gradient-based optimization technique. But, so that's the policy. And then you have the value function. And the value function is basically what the policy uses to evaluate all of the data and see which parts of that data are going to be most relevant for the objective. So that's how you think of policy and value functions. I know that they can be very confusing, but policy is the high-level algorithm that's basically like the god, the architect that's deciding everything, and it's learned over time. And the way it's deciding everything, I'm using my hand as a kind of visual aid here, as it's looking across the environment top down. The way it's deciding everything is it's actually evaluating all of the possibilities using a value function. And so the policy uses the value to evaluate all the possible next steps in a simulation, and then it will index all of those possibilities from most valuable to least valuable, and then it'll take the most valuable step, and it'll continually do that every time step until it gets to the objective. So that's the idea behind policy and value functions. So let's keep going here. So in our policy, let's say like a very simple policy is going to be like value 1, value 2, value 3 equals the observation, and then we have some kind of like if statement that's like if value 1 basically we want to say like if we get to a certain point, if we got the reward, we want to store all of those states that we had. So let's say that the policy will be like, I'm actually like thinking, I didn't actually finish this before this because I was so busy setting up the PC. So I'm actually thinking about this in real time with you together. So if we have this policy, we're returning all these values from the observation. These are like the pixel values for all the images, the image frames. We want to update this AI such that it's going to make the next best step in the next time step. And so we could say that if So the policy requires not just the observation as a parameter, it also requires a reward as a parameter. And so what happens is, like, if we get a reward, then we want to store all of those episodes. So we want to make a distinction between episodes. We only want to store episodes where at the end of a certain threshold of time steps, we receive a reward. We want to discard all of those bad episodes. And then we compute what's called like a discounted reward. Let's actually look at the math formula for this. I mean, the math formula actually does help a lot of times, like, write code. If you like understand like some basic math formula, like what you're talking about, you have to know. So let's take a look at that. So so in this, like, it's like, it's called Monte Carlo prediction formula, or like algorithm. That's going to help us write the algorithm. Because I know, like, generally it's like random, and then just like, and images are almost always better explanation tools than words, just because, you know, at least for me, I'm a very visual learner. So no, not algorithm, pseudocode. That's what we're looking for, pseudocode. And not even Bing. Bing is fine. So, right, so we have a counter, and that counter would be the episodes. We're storing all the episodes in this counter. And then, okay, this is looking at it in the form of a graph, but we don't need a graph. We just need the formula, actually. Just remember, like, yeah, this is what it was. I think it was that one. Oh, you know who had a good one? Denny Britz, my favorite. Denny Britz, reinforcement learning. Such a good one. This dude right here. Oh, yeah, that's the good stuff. Look at that. Which of these? We'll just pick and choose our algorithm. Monte Carlo. There it is. Monte Carlo prediction. So here is the Monte Carlo prediction formula. So, okay. We initialize a set of vectors, and then we have an episode, and then we store the tuples just like we did, the state, action, reward tuples. And then this is the part, this is the learning part without the neural network. So this is like the non-neural learning, like the very basic learning part, where we find all the states that we visited in an episode and we convert each to a tuple. Okay, fine. And then for every state in that episode, we're going to compute the first occurrence of the state in the episode and then sum up all the rewards with a discount factor since the first occurrence. So it's like a decay factor of rewards that gets greater and greater the closer we get to the reward. And then we store all those values associated with the states. And so states are getting values associated with them, which helps our policy, in this case it's a very simple policy, decide what action to take. So again, no neural learning, no deep learning here. It's just like very basic policy, Monte Carlo prediction using policies and values. But so that's the idea there. I do want to get to question 3 now. So now we're going to get to question 3. So question 3 is, it's about something that I just talked about. So take your time to read this. Don't just answer. Take your time to read this one. Let me read this one with you. So neural networks sometimes require holding huge amounts of data in memory during training, right? So batch training. Tesla's train on 4,096 images per training batch, for example. And I learned that from Andre Karpathy's talk last night. I was watching PyTorch at Tesla, and just a huge, there are 8 cameras on the Tesla, and just think about the amount of image data that's going into the Tesla's processors during a single iteration of the training loop, just a massive amount of data. And so how do we enable that kind of functionality? How do we make a system that's able to process just giant amounts of data? Is it A, we clean the data? Is it B, we ask Elon? Is it C, distributed computing? Or is it D, blockchain, because there's always blockchain behind everything? And that's the question for you. Let me answer some of yours questions. Can you ask him? Related title asks if he's tried GitHub's own CLI. Yeah, I have. I have tried GitHub's own CLI, and I think that all of those GUI programs for GitHub, or any of the programs that GitHub has created, are great. But I like rolling my own. I don't like using GitHub CLI. But I also don't like helper tools that much anyway. I think the better you get at any given technology, it's almost like a general rule I found. The better you get at a given technology, the more low level you're comfortable with. And I think that I really like the Unix shell, and I never really liked any kind of Git GUIs. Like, that's not my thing. Graphical user interfaces. Suhail Sumra asks, what are the key components for building a custom PC for deep learning and game development? Well, you need the GPU. I feel like I've already stressed that enough. It's like you start with the GPU and then everything else comes afterwards, because deep learning requires parallel processing for those neural networks, for those matrix math operations. If you want something to train in like a day or less and not like a million years, you're going to need a good GPU. And then it's about everything really supports that GPU in terms of the power supply needs to have enough power. The motherboard needs to support it as well. And that's really it. And then, of course, everything else is just nice candy on top. Get some good amount of RAM, get some good amount of memory, and then we can see what happens. I might stream some code Cyberpunk 2077 for you guys in a second. But let's now see what the answer was. I feel like everybody got this one, or most people got it, in 3, 2. Oh, one more question, actually. Nadir Abdul Haq asked, TensorFlow versus PyTorch, pros and cons. I got to make one of my yearly deep learning frameworks videos, don't I? Look, I think that PyTorch, clearly the whole machine learning community now prefers PyTorch. That's now like a thing. But weirdly, I'm sticking with TensorFlow. I find myself installing TensorFlow, and just because of it just seems like it's going to have less compatibility issues. Just getting things set up is a huge challenge, right? If you can get past that initial barrier of getting your environment set up, then you're good, And so that's why I think that TensorFlow has been around longer. So generally there's more documentation, which means generally it's going to be easier for you to set up. But PyTorch has got the dynamic computation runtime. So it's got that runtime graph. The graph is generated at runtime as opposed to compile time, which is better for recurrent networks or networks that grow and build and are dynamic over time. So in that case, PyTorch is better. But I remember that TensorFlow added something on, like it tacked on something to allow for that. And so I'm going to still say TensorFlow. Let's see what the answer is. 3, 2, 1. The answer is distributed computing. If you got that correctly, you are a hero. Congratulations. And let me announce the winner, shall we? The winners, rather, one by one. So we're going to have 3 winners. Let's see who they are. View the results. Dun, 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 dun. This is like some Jeopardy music. We've got John K. 1998 at yahoo.com. Shout out to John K. John got all 3 of them correctly. Let me save John's name. We've got John K. So that's our first one. Who's our second winner? Our second winner is Naota Isakari. Congratulations, Naota Isakari. You got all 3 of them correct. Naota Isakari. Love that name. Sounds like Japanese sounding. I don't know. It's really cool. Naota. One more winner is we've got one more winner, and that is Nadir. Just Nadir. Nadir, nice work, Nadir. Very proud of you. We've got our 3 winners, our 3 heroes for this live stream. John K 1998 at yahoo.com, Naota Isakari, and Nadir. Congratulations, guys. You guys are amazing. That is what I love to see. All right. I guess I need to do a song for you guys now. And then maybe next time I can stream Cyberpunk 2077. All right. Here we go. Let's see what I've got. I've been listening to a lot of trance, guys, like all this week. I've been listening to I've been listening to a lot of trance music lately, so I'm gonna play some trance beats. Congratulations, John K, Naoda, Isakari, and Nadir. I'm gonna do a freestyle song for you. Here we go. Yeah. Woo! Throw your hands in the air. Got our 3 winners. Yeah. Here we go. Got my GPU. I see through you. C3PO. That's the robot. John K. My Naota. I'm my GPU. I'ma try to follow the gradient. Follow the gradient. Oh, I like that the way that sounds. Follow the gradient. Follow the gradient. Yo, John, follow the gradient. Noda, follow the gradient. Nadir, follow the gradient. Follow the gradient. Follow the gradient. Follow the gradient. Yes. Damn, that's lit. All right. That is a lit beat. Thank you guys for playing. All 3 of you, you know the deal. Email me hello@sirajraval.com in the next hour, and I'll send you the $50 in Bitcoin within the next 24 hours. Usually I do it within an hour after they send me the email. So congratulations, guys. Thank you, everybody, for being here today. We're going to do this stream same time. I want to say the same time next week. Oh, no. Next week is Christmas. I have to visit my parents in Houston for 3 days. So I will still try to do one next week. Let's do that. And I'll schedule it within like 48 hours. I'll just do it on like Thursday or like maybe even Wednesday. But I love doing this every week, guys. I'm not stopping. So I just want you to know that. If you haven't signed up for the Play Code Royale playlist, waitlist, please do that now. We're about to close it up. And thank you guys for being here today. Maybe next time we can stream Cyberpunk 2077 and it won't lag out. And shout out to our sponsor, Zilliqa, for sponsoring this video. They're a blockchain that implements sharding and a bunch of other custom solutions. They're a great team, and you can see links to their product in the video description. They sponsored the rewards for this, the prize pool for this live stream. So thank you, Zilliqa. Shout out to Zilliqa. And so thank you, Zilliqa. And so what else? Anything else to say during this live stream? Guys, I really just love these live streams, and I love you guys, and I'm just really enjoying this. This is a lot of fun, and great things are coming, guys. Code Royale is coming. I'm working my butt off on development. Spent maybe like 70,000 so far on development for Code Royale, which is a huge amount of money. But January 24th is going to be the release date. If you haven't joined the Discord channel to just chat, make friends with community people, just get in that Discord, start chatting with people, make friends, and I will see you next week. Or if not next week, then the week after that. All right, guys? Take care. Have a great day. Have a great night wherever you are in the world. And I'll see you soon. Bye-bye.